Hi, so I'm Michelle Dion. I'm the academic director of Spark, and today I'm going to talk briefly just a little bit about outliers. And so the first thing I want to start with is kind of like, what is an outlier? Um, I feel I feel a little shy putting you on the spot, but kind of in plain language or what you remember, kind of what's the best way to describe an outlier?
Can I use just one word?
Yeah,
It's an anomaly, which is not uh, their usual thing. Like if there are 10 people doing the same thing, what is that one person who is not doing the same thing?
Yeah. So it's maybe one person that doesn't fit our expectations very well.
Yes,
They're an
yes.
anomaly. They're a little bit of an odd duck.
Yeah.
That could be an outlier. You could also have entire jurisdictions or places that maybe have performed a bit differently than their neighbors. Maybe they've adopted different policies or have different characteristics. But yeah, the idea is generally that it's kind of a case or an observation that isn't well explained by our theory or model. We don't know why this person or this place isn't quite like the others, but we can see that it's not. And in regression analysis and regression based methods, we kind of have a more uh, technical definition, which is that an outlier is some sort of observation that has influence on the parameter estimates, meaning it changes our findings in some way. It skews our results. It makes our results be something other than they would be if that outlier weren't included in our sample. So the illustration I have here to kind of illustrate it is imagine you had some sort of data for some people, and all you had collected on them were their salary, their experience, and whether or not they had some sort of terminal degree. And so you might be estimating a linear regression. In the real world, salary doesn't increase so linearly, and it also is not so tight around the prediction line. But for illustration purposes, you might have data that look like this, where each additional year of experience and a degree tend to incrementally be associated with higher salaries. So an outlier might be somebody who doesn't have a lot of experience, but for some reason is making a lot more money. Maybe they're the president's family member, or maybe they are friends with whoever runs the company, and they got hired with a much higher a much higher salary despite their low level of experience. Or maybe we just don't have the right information entered in our data set for their experience. Maybe they really are experienced, but this is a reflection of some poor quality data. We don't know at this point, but what you see is that when you have an outlier, a dot like this, that moves the regression line, that shifts the regression line here, it's not very dramatic, but it does move the line a little bit. That would be um, suggestive of an outlier. You could also have someone who's very, very underpaid and has a lot of experience, and they could pull the regression line in the same direction, but be on the other end. So essentially, this is just to illustrate that outliers tend to be these observations that move our regression estimates move our or change our estimates of the parameters because they are as Grima said, atypical, right? They kind of don't fit the pattern that we have in mind for explaining our data. So the general definition is still true that these are just observations or cases that aren't well explained by our theory or model because they don't seem to fit our expectation. So the next thing then is kind of to think about, well, what should we do about them? And my position is that it depends. Um, There are some textbooks that will make very strong recommendations about what should be done, but I think the more nuanced approach to data analysis is to say, it kind of depends. It depends on why that observation is an outlier. So I would start with the data generating process. What do you know about the data generating process? Are these experimental data? If they were experimental data that you collected in such a way that you were able to control certain aspects of the data collection, maybe that increases the chances that the data are bad. Maybe it's a mistake. Maybe there was some sort of error in data entry. And if that's the case, then maybe you do want to throw away those observations because they're in some way fouled in the data generating process. Often with observational data, we can have that happen too, but we may not know that unless we collected the observational data ourselves. But still, you want to kind of stop and think about the data generating process and what you know about where the data came from, how you came to own these data, and ask yourself, is the outlying data point a data collection or coding mistake? Or is it really one of these instances where it's an observation or a case that just doesn't fit very well? That's kind of the odd duck that doesn't that isn't well explained by your theory. The next thing you should think about is your theory. How good is my theory? How robust is my theory? Does my theory omit important theoretical explanations? Kind of returning to Garima's explanation that it might be a person who kind of doesn't fit our expectations. They do things their own way. Well, maybe our expectations are the problem. Maybe we just don't have good theories to help us understand the motivations or the preferences or the attitudes of people like that odd duck, that outlier in our data set. And so it's always important to keep your theory as a touchstone, go back to your theory, think about is how complete is my theory? How much does it really account for the full variation of kind of the observations I'm going to see out in the world? And then if it turns out that you come to the realization, well, you know what? I could explain this kind of odd behavior or this outlying outcome with a new theory that I found or a theory that maybe I overlooked, then the question is, well, can you measure that omitted variable for all your observations? Is there some way that you could incorporate and improve your theory and improve your model by adding some independent variable or some characteristic that would help explain the outlier, that would help you kind of add, make that outlying observation less of an outlier through explanation based on theory. I also like to point out that outliers can be opportunities. They can be opportunities for theory building case studies. So there's one person in an organization who appears to be an outlier in your analysis. Maybe it's time to do an in-depth study with that person to understand what it is about their experience or their perspective or their behavior that maybe could be explained. And then you can expand your theory or incorporate those insights into a new theory that then you could test with a new data set. You can also, if we're talking about, cases as observations, jurisdictions, different places, different organizations, maybe you decide to do a case study. Maybe you do a case study on the firm that is an outlier or the country that is an outlier. And so there, again, the idea is that you do a deep dive into understanding the outlier as a way to improve your theory and make a contribution to theory, which then creates an opportunity for you to go back and collect more data on your entire observations or your entire data set and potentially have a follow-up publication that kind of demonstrates that now these outliers are no longer outliers because you've built this new theoretical explanation that helps account for them. So some last resorts, and these are the things that textbooks tend to recommend, would be to kind of omit outliers from the analysis. And so I like to kind of think, what are the pros and cons of this? What if it turns out you have 3 countries that are outliers, or you have 4 people in an organization that you've surveyed and they're outliers, and you just kind of throw them away? You exclude them from the analysis. You say these observations are kind of messing up my analysis. They're outliers. I'm just going to delete them and not analyze them. What are the kind of trade-offs that you face there?
I think one thing would be that we would lose valuable information. Let's say, like, something is very influential. You'd want to sometimes maybe keep it into the model.
Yeah. You're throwing away data. You're throwing away important observations that, if you've ruled out mistakes in your data and they really are outliers, um, if it's observational data, we don't really just want to throw away that information because it's true. It's, their existence as an outlier kind of tells us something about the limitations of our theory and also about the need to kind of think more thoroughly about those cases so that we can improve our theory. So, yeah, you're throwing away information that you've already collected. And if it's good information, um, if it's accurate information, we would prefer to kind of develop better theories and better models to explain it. Um, One of the advantages of it then, though, is that if you kind of deleted those observations, your model certainly would look pretty good, right? It would improve in terms of its fit, and you would have kind of nicer looking results. But as Rochelle points out, the con of this is that you've done this in sort of an artificial way that isn't actually capturing the range of experiences in your data set. So, when might you do this? Well, I think omitting outliers is a tricky decision. I think you have to kind of think about these pros and cons and think about what you know about why that observation might be an outlier before you decide to omit an outlier from an analysis. I'm not saying that it's never appropriate to delete outliers. I would just say that I'm probably a little bit more cautious about that, kind of like Rochelle, than some textbooks I've seen that kind of just willy nilly say it's okay to delete the observations that don't fit. One other strategy that I've seen used is to include a dummy variable for the outlier. So, for that one person, you just include a 0, 1 in the regression or in the analysis that kind of tries to adjust or account for that one observation, or maybe it's 2 or 3 observations, or you include a dummy variable that estimates a new uh, intercept for just that one, just that one country as a sort of nod to its exceptional characteristics. Um, kind of what does that assume, and what are the limitations you think? Just thinking about kind of keeping the data, keeping the data point in the sample, but then just in your model, kind of including this one indicator for like, okay, this one point is a little bit off. This is a little bit tricky. It requires a little bit more um, knowing where I'm going to get the answer. Well, when you think about what does a dummy variable do, it just shifts the intercept, right? It just changes the overall average outcome in a dependent variable or the predicted probability. If we're talking about something with a more limited outcome. And that still assumes, though, that all the other coefficients are going to be accurate and are going to and that outlier is explained and kind of incorporated into those coefficients accurately, right? So adding a dummy just for the one or handful of observations really only kind of fixes the dependent variable problem and the fact that they're very different on the dependent variable, but it might not do a good enough job mitigating the way that the outlier is affecting the other coefficients in the model. So it's kind of like a technical limitation. Um, but it is something that I have seen in published work that sometimes researchers include a dummy for common examples I've seen in the developmental economics literature are for Botswana, because Botswana in sub-Saharan Africa has much higher governance standards and outcomes than many other countries. And so Botswana is often kind of an outlier and treated it through a dummy variable. And in other studies, I've seen kind of the entire sub-Saharan region of Africa included as an Africa dummy, as a way to kind of say, we don't know what's going on with this region of the world, but our economic models don't explain it very well. And this is a prime example of a place where I would say it's better to kind of think about your theory and go study that region and come up with better theories than to just kind of dummy away the outlying region of the world. So we have a few minutes left. I have an applied example that may or may not be real. But imagine you have a study where you're studying salaries at a major university, say in Canada, maybe even in Ontario, and you have a model that you think is pretty complete because it accounts for years of experience and academic rank. And you have kind of a set of dummies for what discipline or faculty they're in because, um, the business faculty always earn more than the humanities faculty. And then you have a binary sex indicator for whether or not the faculty member is male or female. So we have a data set of all the instructors, full-time instructors, and we have these characteristics, and we're trying to understand what drives salaries. And then once you've done the analysis, you notice that there are several outliers and that all of these outliers are significantly overpaid according to the model, which means their salaries are many standard deviations above or many standard errors above what the model would predict. And it turns out that all of these overpaid outliers happen to be men um, from various different faculties with various different levels of experience, but they are all men. What do you do in this instance? Do you delete them? Do you dummy them? Do you what would y'all do in this case? Thinking about our model also. Our model only has years of experience, academic rank, what kind of general discipline they're in, and what their gender is. What other things uh, do we delete them? Do we add new indicators? What would be your first step?
I think in that framework, yeah, ads. So it's, I think, adding new indicators, not deleting them for sure, not deleting them.
Mhm.
I think
And why
it's an
would you not?
opportunity. It's an opportunity to find out why it is the case.
Mhm. Yeah, so you wouldn't want to delete them as long as you know the data is correct. You've verified that they really do make those salaries.
Yeah.
So what are some other indicators? I think, Rochelle, you know a lot about this area of research. What are some things that this model doesn't account for that maybe would explain why some people make more money than others?
So it might be publications, it might be grants that they're bringing in. So it could be like so-called measures of productivity that we're missing.
Hmm. Yep. So it could be because we haven't accounted for productivity. It could be that all these statistically overpaid men really do deserve these higher salaries because they're bringing in more grant money, they're writing more papers, they're more productive. And therefore, if we included some sort of indicator of productivity, they would cease to be outliers. So that's one possibility, is to think about additional characteristics that go into salary decisions. Maybe it has to do with external experience. Maybe these are all men who came from industry and brought a lot of industry experience, even though they don't have academic experience. And so maybe they were able to negotiate higher salaries as a result of that. So there are, this is a case where I agree with both of y'all that we wouldn't want to necessarily just delete uh, those overpaid men from the data set. In an ideal world, we would want to go back and perhaps identify which faculty members those are, see if they have certain characteristics like high productivity, maybe they have administrative experience, they've been in administration and gotten large raises because of that. Maybe they have other experience that help them garner this higher salary. So it would be an opportunity to think about our model. You can also just go to the literature on these things and then try to collect those indicators for the entire data set, right? And that would ideally, if you then kind of included, say, lifetime grant dollars and total number of journal publications or some sort of total number of citations into the model, then conceivably if those are the factors that are driving this difference, those male faculty members would cease to be statistically significantly overpaid, and we would in fact have a better model overall because we would have a more complete explanation of the variation in our sample. So I have here the example that I've already mentioned that there are in the literature where there are several papers out there where uh, economists have figured out that there are certain regions of the world that underperform or that there are countries or a country in sub-Saharan Africa that um, overperforms. And so there is a literature that specifically addresses these kinds of outlier cases and how to examine or explain them. Um, I'm wondering if you can think of outliers in your own research, some cases that might bedevil your quantitative analysis because there are regions or places that are or characteristics that are hard to measure, perhaps. Well, it's something to think about going forward. Um, I'm just going to wrap up here that if you're a researcher who is kind of finding you're in a situation with some data and some outliers that are puzzling you, the research staff at Spark can kind of help you think about how to do this. And we have access. And so you do have access to researchers and research support to help you think through these trade offs. So thank you for joining us today. And I look forward to seeing you sometime soon.